All right, everyone. Thank you so much for joining us today as we get started talking about KMC Commander and BrainBox AI. Very excited about this partnership. Today, we're going to talk a little bit about Commander and then give a bulk of the time to BrainBox so they can really show off what they're doing and how they're doing it in the building space. Extremely innovative product that we're very proud to partner with, and a very competent and entertaining team, which is also just a simple joy to work with. So thank you so much. My name is Tim Vogel. I am the Director of IoT for KMC Controls, where I focus a majority of my effort on KMC Commander and building out those channels and building out the product. And with me today is Ryan and Cole from BrainBox. Ryan, you want to introduce yourself?
Absolutely. Thank you, Tim. Ryan Dregge here. I'm a senior solution engineer at BrainBox, part of the product and solutions kind of arm of the team. What does that mean essentially within our realm? We see things kind of end to end, working through opportunities as they come to us, and our intent is to best solve the problems of those customers by implementing our solution correctly in their environment. So that means we need to be able to evaluate and work out what will work and what won't, unfortunately, sometimes. My background is primarily based in building automation and controls, so probably not much unlike others on the call here. A tad bit older, perhaps. I cut my teeth on the Andover controls, AC 256, if anybody goes back that far. And then after about 15 years of the controls industry, I found myself working in an engineering firm, and then on into kind of smart building consulting, and worked for a software provider there for a bit before joining BrainBox. So it's been quite the journey, and hopefully I can share some insight, and if not, some color commentary through the hour here.
That's perfect. Thank you, Ryan. And what about you, Cole?
Yeah, so I'm a director of channel sales here at BrainBox, and so I work really closely with our partners who are taking our solution to market, making sure they have the tools they need, they understand the solution. Spent my professional career in sales, the vast majority of that in prop tech, working with various energy management, fault detection, and optimization solutions. So it's kind of right in my bailiwick. I've taken them to market before, so I know the challenge is there, and puts me at a good position to help others do the same.
Awesome. Well, thank you guys so much for joining. Before we get to your part, I am going to share a few slides about Commander, because that is sort of the basis of our relationship in a way, in terms of how we get data out. But right before I get to that, 2 items. This is being recorded, and so please, anyone, if don't worry or be concerned, you'll be able to share this with other people on your team, or be able to go back and reference it if you need to. Additionally, I will be interrupting these guys throughout the presentation. We'll have some time at the end as well for you to add into the chat. If you look on the right-hand side of your screen, you'll see the chat button. Please click on that and add a question, again, at any time, and I'll make sure to interrupt when and where I can. And they've assured me that they will not be offended, so I will take full whatever I'm trying to say. Full advantage. There we go. There's the words. Okay, so KMC Commander. The premise of this relationship is all about integrations and add-ons, where Commander is very good at pulling data out of the building and bringing it to dashboard schedules, trends, and alarms. We also want to partner with some of the leading vendors in the building space, not least of which is BrainBox. They have an incredible platform. And not only are we pushing data to them, but now they are also able to run their algorithms, which they'll talk a lot about, and then push those set point changes back through Commander. So while we are gathering data and interacting with the BMS on site, it is a cloud-to-cloud integration that we're doing with BrainBox. Now, what is Commander? Commander is a cloud-based, internet-based platform that allows you to bring that data up out of many protocols. We're collecting 30 million data points every single day. Our API is being used constantly. We're in over 1,000 buildings now. And being internet-based, it's also important to know that we have a very high level of uptime, 99.9+%. Now, what buildings can we sit on top of? Many of you know that KMC Controls is a controls manufacturer with a full line of BACnet solutions, but we can sit on top of nearly any system that is out in the building environment. Commander communicates 3 primary protocols: BACnet, Modbus, and SNMP. And if there's anything that's more specialized that is local to the site or the facility, we're able to also do custom API calls if necessary. But if you look at these, this is just a sample of those 130 brands we've integrated to date. If anything is proprietary, we have an excellent relationship with Tritium, and oftentimes we'll use their driver set to push that data out BACnet or Modbus. So again, you can put Commander on top of anything. And once that's done, you can now create very easy to create dashboards that uses elements called cards and decks. Cards come in multiple different flavors, as you can see across the top. And then a deck is a revolving carousel of however many cards that you need to put into that deck so that you can maximize the space. And it also maximizes the uses for mobile connectivity. Other ways that you visualize data would be through a web card or a large trend card, and gauge and KPIs and anything coming out of the building that needs to be visualized and contextualized. Not only do we have dashboards, but we also have multiple other modules that allow you to look at that data and analyze it, whether it's our trend module or our alarming panel, which allows you to set different parameters of any of the data points that are coming in, and then alarm or notify a single person or multiple people, acknowledge it, and that. And then also schedules. When do you want things to run? All of that can be controlled via the cloud across an entire portfolio in a single unified cloud-based platform without having to replace your multiple BMSs throughout that portfolio. The other thing that is nice about it being internet-based is that means that now you can manage your building from anywhere. And whether you're at the top of a building or down closer to the ground or in another country, wherever you have internet access, you now have access to the data coming out, and then also the ability to not only monitor, but control. So that is one of the really exciting things about working on our platform. The other thing that's exciting is in the next couple months, we'll be getting more information out about our new UI that will be coming at the end of January in Q1. We're very, very excited about this. It's going to come with all kinds of new functionality as well. But again, today, what the bulk of the time is going to be about is BrainBox. So inside of a building, we're going to put a gateway. That gateway is going to collect the data via those open protocols and streamline the communication in a very secure way to the cloud, where you get your dashboard, schedules, trends, alarms. All that data is now open via API and can be used in multiple different use cases, including BrainBox AI, who's going to take the data out, run their algorithms on it, push changes back into the Commander cloud, which then gets propagated into the building and BMS itself. So that's why we're so excited to bring BrainBox to you guys and to talk about them. And with that, I'm now going to turn it over to the BrainBox team. So thank you, guys. Go ahead and take it away. And remember, anytime, if you have any questions, please add them to the chat. We'll answer them not only in real time in the chat, but I'll also interrupt the BrainBox guys. With that,
anytime.
Anytime.
Thanks, Tim. Anytime.
Cole, we have our first question. I'm just kidding.
Oh my goodness. That was quick. Yeah. So like we were saying, Commander provides a really interesting opportunity. The more data we can get into the cloud where everybody can use it, the more interesting things we can do with it. We're part of that ecosystem, and so we want to share with you the powerful effect we can have on that when we get it there. But why are we doing this? Why is there an opportunity for AI in commercial buildings in the first place? We've done a lot of work. Most of us are from controls companies, but those controls are limited in what they can do on site. HVAC systems are reactive and schedule and rule based, and buildings and environments and people are not. We can get really far by plugging in a thermostat, putting in a control system, setting a schedule. We can get pretty far But as we get into this today, we're going to show you how that's really kind of cruise control. And what we're talking about is the self-driving car. A little bit of background on BrainBox. We've been around for a little bit, just over 2 years now officially. And in that time, we've grown really, really rapidly into over 100 million square feet of real estate. And our team is growing in leaps and bounds. I think it says 130 people on that slide, but there are like 3 new messages from HR every day, and I can't even keep track. And we are headquartered in Montreal, Canada, because as we'll note, we are an AI company, and that's a big hub for AI. Somehow, through the last 2 years, which has not been the most convenient time to kind of go to market during a global pandemic, but despite that, we've managed to really expand very successfully, primarily in North America, but across Europe, Asia, the South Pacific, the Middle East, and even some limited deployments in South America. We've gotten a lot of attention during this time. Last year, we were recognized by Time Magazine as one of the top 100 innovations of 2020. And just when our marketing team, we thought they couldn't really top themselves there, we were just awarded the top innovator at the United Nations COP26 climate conference in Glasgow about 2 weeks ago. So it's so fresh. This isn't even a marketing approved slide. I just grabbed an image off our website and threw it into a PowerPoint for you guys. So before we go into what we do, I think it's really important we give a little bit of context on AI and deep learning, because that's a buzzword, right? Everybody's got AI these days. Everybody's got machine learning. So Ryan, why don't you help me contextualize AI and break it down to the level that BrainBox is actually manipulating?
Absolutely. Thanks, Cole. So unless you've been living under a rock, especially in this industry, you're probably familiar with at least the term AI, artificial intelligence. We see it everywhere. Everybody's using it. You're probably using it and don't even know it, to be quite honest. So to that, this is kind of the basic rundown. You've maybe seen this before with other folks. It's not unique to us. These are kind of subsets of what we're looking at. So AI in itself is what it says here. It's an enabler to mimic human intelligence or activity. So it's a decision-making ability. Probably not too far from what your standard if then this kind of logic is. It just has a little bit more power behind it. Within that is the subject of both machine learning, and then even deep learning would be the next step down into that. This gets into kind of the learning experience that AI is enabled to do, such that if you've heard the example of showing pictures to an AI engine, which are depicted in not visual reference, but kind of ones and zeros. But if you use kind of a human onset to that, is this a cat? Yes, no. Is this a cat? Yes, no. Is this a cat? Yes, no. If you look at enough of those, the AI is able to determine. So it's a feedback loop. It's a human-initiated feedback loop. In fact, if many of you have done the kind of Captiva, point out all the pictures with stairs in them, that is a learning exercise for AI. You are assisting the Skynet when participating in that, for lack of a better term. But that is kind of the technology that we're using. So it means we are training models in that type of mannerism and using that to our ability. Specifically in our instance, what we are doing kind of as our NEAT AI is creating a predictive model of the space. So we actually create this neural network that predicts. So it is making decisions and then causing predictions, which is kind of, I think on the next slide, we get into kind of the recurrent neural network. So it's essentially taking a data set and expanding it beyond where the data set is. So that's part of what we're using in our ability to do that. And kind of the point of this slide is more basic, just to kind of say that AI is out there. It exists everywhere. It's not really magic. It's math. It's high-end math. You hear a lot of stories about kind of the Watson computer everybody knows about. We are not Watson. That is a $30 million computer to play Jeopardy. The carbon intensity of that PC probably would outvalue it in our sector, but that is one extreme. But there are more simple yet complex variations of the technology, and that's what we're using. And what we show here, so your voice recognition in your phone, kind of your predictive text if you use that, obviously translation. These are all types of bits that are AI. Chat bots, the ability to kind of predictively answer and ask questions is another form of AI. If you want to get into the next slide there.
Yeah. Well, I once heard it explained really, really well and really simply. So if I'm understanding you correctly, so AI is sort of the category, and as we get more specific, we're getting closer and closer to neural networks. And what I heard it explained once, the closer to true AI you get, the less you can easily explain what it is, right? Because like you said, it's math, and it's, A plus B equals C is one equation, but then the more complex that gets, the closer we get to AI, right?
Exactly.
Okay.
And that's kind of where we try to, value set ourselves next to your traditional BMS, which is obviously a topic of discussion here. PCs are what they are. Controllers are what they are. Probably most people on this call have, approached the ceiling, perhaps, of CPU use inside a field controller. You can do a lot in there. You can't do everything. So we're trying to enable these systems in place by allowing further intelligence and creating the pipeline to use that.
Yeah. So let's go back to the analogy that's kind of on here. If what we have today is cruise control, how is BrainBox the self-driving car?
Yeah. And I'll be a bit transparent. This isn't my favorite analogy, but we do use it, and it does make sense. I kind of, being an old BMS guy, I like to stand on my morals and say that BMS are pretty powerful. But to your point, it is a cruise control for the building. So we've built them to maintain and operate to the specifications at a given time during installation or design. And that's great. And they work well, and they're efficient to a means, and they know what they know, and they operate. So we would consider that kind of cruise control. They can run, they can, keep speeds and do that kind of thing. What we really are, or what I like to think is, we're more the adaptive cruise control or lane containment technologies that are a little bit more dynamic. So we've got more points of input and more processing power to make sense of it. And specifically speaking, we send your data to our cloud, we create that neural network, and that neural network is built out of now your interval data. So it's getting robust as it's growing in time, and this forecasted and real-time weather application. And what that looks like from a high level really is a ton of data points that are all in correlation, or at least in comparison. So it's every point to every point. That's the unique bit about a neural network, is the netting in between it. So we are looking for correlations and causations, or I say the AI is looking for correlations and causations, to what degree we can find them, and using that intelligence to kind of predict what's happening in the space. So I can watch a vast set of variables in weather, and we all kind of know weather is the reason that we heat or cool buildings, or we condition buildings, is because outdoors is not great at certain times. In certain areas, Cole, you're probably fine outdoors year round where you're at. But that being said, we are trying to find out how those interactions make sense, and we're able to very effectively do that, and then predict this intelligence into the space. So if I know that the space is going to have a rate of change of a certain amount, or going to reach a temperature within a certain time frame, I can use that in my decision-making ability, and that's kind of what we do in a nutshell.
Yeah, we'll dig much deeper into that in a little bit, but the trick used to be, someone from anywhere can jump in and manage that building. You don't have to be an operator sitting in sub-basement level 2 on the workstation. But we've gotten to the point now where the trick isn't having a human from anywhere who can manipulate the building. The trick is not needing one. And that's really, this is a resource we put on top of the building to make all these changes that, if someone was looking at that 24/7 with all of that extra data, they could. But at the end of the day, you've got more valuable things to do. So what are we delivering? Why are we doing this? Really trying to make buildings a lot more efficient at the end of the day, and through moving away from that more static process and treating buildings in the dynamic fashion that they truly are, there's a lot of benefits that we can add. First and foremost, as Ryan was just saying, we're solving the outdoor temperature question, and that's comfort. It's often written into a lease. It is the thing that's going to impact that building, whether it's, you're the operator and you don't want to deal with complaints, whether you are the retailer and you need sales, whether you are the tenant and you need people efficient and comfortable. Comfort is the reason that building is there. So that is kind of first and foremost what the AI is looking to deliver. We're not looking to hugely manipulate the thermostat so that we can save a little bit of energy. We're working backward from whatever the desired temperature in that building is and improve it wherever possible by staying closer to it. Next up, these last three are all related, and it just depends on how you're looking at them. But what the AI is looking to do in being efficient is not running equipment. When we don't run equipment, that equipment lasts longer. When we don't run equipment, we save energy. When we save energy, we reduce GHG emissions. And it just depends on which entity in the building we're talking to as to who's going to care about what. The ownership group, the REIT, might have a stronger directive towards carbon footprint, whereas the facility, the property manager, the operator might have a stronger directive toward operating expenses. So all of these things end up getting factored into how the AI interacts with the building. And we mentioned it a little bit. Again, it's not automagic. There needs to be an existing system that we can talk to, and this is where Commander comes in really handy. Again, the same thing. We're going into an industry that's very fragmented. There's a lot of brands. There's a lot of different kinds of systems. And so we need something that's modern, that's able to work with us. Commander solves that problem for us. It allows us to get access to this data and to build that model. Once we've got access to that data, as Ryan was saying, that's when the AI builds a predictive model that is 99% accurate 4 to 6 hours in the future. And if that AI can predict exactly what's going to happen, it can manipulate the situation to achieve one of those goals we saw prior, or hopefully all of them at the same time. Now, we are talking about software, but it is important to note, while we're all familiar with things like dashboards and heat maps, this is closed loop. This is an AI. So once it is plugged in, this is the black box that makes all of the actions by itself. So it learns, it builds that predictive model. It compares that predictive model with its actual performance, and it continues to act, and it continues to improve. Brian, anything you'd like to add to that as it's related to AI?
No, I guess an important part here, and we can get to the Q&A, I'm sure, at some point, but a question we get often is, how long does it take to learn? How often does it learn?
Does it keep learning?
Does it keep learning? Yes. The answer is loosely yes, and it takes what it takes. So there is a data constraint, and I want to say it's about 10,000 samples to kind of create a robust enough database to really have the ability to learn. So there's a time constraint to that if we're looking at 5-minute interval data, right? So that's a real thing. But what we are essentially doing is looking to learn, and there's some human effort in there as far as tuning these things. But it's that point of accuracy, and then we have a deadband or bandwidth of what is an acceptable level of accuracy. Roughly, I think it's 99.6, and I'm not sure what the real bandwidth of error is there. But as it would track away from or towards that, it's continuously learning too. So realistically, what's happening is the data sets get more robust, it's growing, it's getting bigger, the learning gets better, to be honest. So it is kind of a continuous loop of learning. I guess much like all of us, it's constantly re-educating itself.
Yeah, perfect. And so what does this look like in action? In its simplest form, I mean, there's a lot that's going on when it's performing those minor corrections every 5 minutes based on that predictive model. And here it is just extremely simplified in its simplest terms. So we have an existing building, and you've got, like Ryan said, you have your deadband. You've got your heating and cooling set points, and temperature is going to generally fluctuate between those 2 points. So in a typical scenario in a building, we've got a scenario here where we've got rising temperature, and you can see the gray line is a typical control system. We've got rising temperature. We have our cooling set point, and when that threshold is met, we've got an alert or alarm or a sequence that is then activated to correct that. Buildings have a lot of thermal mass and thermal momentum, so there's a little bit of a delay, a little bit of a swing, and that's kind of how we go back and forth through our day. What BrainBox is able to do, because it can see the future, it gives us essentially clairvoyant wall sensors, because we know that's going to happen. We can preempt that scenario while balancing, again, equipment runtimes, reducing energy, and if you notice, what we're doing here is sort of artificially narrowing the deadband at the same time. Again, every 5 minutes. And I pulled a couple of slides to show you what this actually then looks like over time in a building. So this is just a couple examples. There's an air handling unit. This was about a 300,000+ square foot building, had an Energy Star score of 85. So we know that someone was paying attention. This wasn't this building wasn't dead weight on the portfolio when we went in. And we were able to reduce the use of the cooling coils and the fans by about 50%, or I think 50%, and the fans, I've got on the next slide, about 41%, 45. And you can see BrainBox is the AI is just looking for opportunities to scale back, and most importantly, to do that without compromising comfort on the zones. So that's something that we've got eyes on too. So here's sort of an audit. And I know there's a lot of numbers on the screen right now. I hate it when people do this. So I'm just going to summarize this really quick. So we were looking, the key one here is set point deviation. And I think I can do this little trick with my mouse if it uses a surprising amount of computer resources to use this fake laser. Without BrainBox AI, the typical zone deviation was about 2.1 degrees. With BrainBox, we were able to bring that down to 2 degrees. So you can see we're actually improving the comfort, even though we very significantly reduced the runtime of those assets, reducing a lot of energy, curbing a lot of carbon emissions in that building. Now, as to what kind of buildings we work really well in, it's a long story. It's an exhaustive list. We like buildings with people in them. And we're a young company, so we like buildings where we're going to go after a larger chunk of what's in there. So big office towers are our favorite. We like schools. We like malls, depending on their lease structure. And so here are just some examples of some interesting metrics we've been able to dig out of our portfolio. And you'll see that some of these are focused on energy reductions. Some of them are focused on runtime. And I think some of these are focused on comfort too. And again, the AI is balancing all of those things. Comfort wins first, and then it's a facet of looking at energy reductions, both as a calculation of total energy, but the AI is also ingesting rate and tariff structures. So it's looking at total energy reductions, but it's also looking at opportunities for peak shaving in the scenario where that would actually be worth more.
Hey, Cole, we got our first question.
Love it.
It's asking about old buildings versus new buildings. Seems like this is for old buildings. Does it also work for new buildings?
Yes and yes. Question would be kind of how new are we talking? We've only been around for a couple years, so if we started our company and we were entirely focused on kind of the bid spec market or new buildings, I probably wouldn't have anything to show you yet. Obviously, the largest stock of inventory is going to be existing buildings. There are some, I don't know, Ryan, have you been involved in, we've been on some very, very new projects. Have you been involved in any of those?
Yeah. So I'm going to speak candidly and transparently because that's kind of my thing. Existing buildings are kind of the easy target, right? There's a myriad of reasons. One, they're probably out of whack, and we can straighten some of that up. They may have kind of older codes and standards in place as far as operations, so we can help better that very quickly on top of kind of the benefit of what we're doing at the AI side of things. Existing building or brand new buildings, rather, it gets tricky for a lot of reasons. Probably number one is building commissioning. So it's going through a commissioning effort. There's warranty in place probably on those goods and services that were handed off to the client. So how do we layer into that? Ideally, in those situations, we're brought in early on. So we're a known entity and can be part of those commissioning efforts and moving forward. But as we're hitting the market currently, we're kind of afterthoughts on buildings that are either going through commissioning or just out of commissioning. So there's some commercial conversations that have to happen to kind of make that work. So the solution itself is feasible in both environments, but there's just kind of ancillary conversations and thoughts that need to be had in those new building situations. If it comes up, we're happy to assist in those. Yeah,
great answer. I think so the short answer, yes in both, easier in existing, and it's largely kind of I'll call it the political situation involved in kind of bid spec work and getting the sign off on a new building that makes us a lower priority there.
Well, and another thing too is new buildings drift just like old buildings do.
They absolutely do.
Helps with that. And kind of a follow-up to that question then was, is there an ideal building? I think these last two slides sort of started.
Lots of human occupancy and kind of a direct responsibility for energy spend. Office towers, just for a number of different reasons, end up being kind of our bread and butter, especially kind of the Class A office towers where they're in the private sector. They're in the private sector. People aren't afraid to throw money at them. These buildings have to attract kind of top tier tenants, and they end up being a very full service lease model. So there's no disincentive that you're going to run into between who's paying the utility bill and who's actually doing anything about the efficiency of the hardware on site. So office towers are great. A good deal of the public sector is also excellent because they know they're not going anywhere. They're willing to invest in infrastructure that often makes them good candidates for us. They just act a little slower sometimes, so it hasn't been a huge priority for our sales team. I would say, and we'll talk about this at the end, when we have partners out there in the field, one of the best kind of ideal targets is their service base, and that solves some heavy lift for us because the first thing we have to do when we approach a client is find buildings that are going to be good candidates. and it's not easy enough to just say, yeah, anything with BACnet over IP. There's caveats. And, but we know if there's an existing service relationship, we're going to get answers to those questions more quickly. And the chance that we're going to be able to get into those buildings is significantly increased. So, and if anybody's interested, I do have some documentation on that, but I've also given a 1-hour lecture on ideal buildings for BrainBox, and it's much more of a discussion than it is ideal, less ideal, difficult sort of target.
Yeah, I think within the ranks of BrainBox, you could probably get a different answer depending on which group you talk to on ideal.
I've seen that, yeah.
There's easy, there's interesting, there's fun. There's all different metrics to measure that against.
Yeah. Sales is going to prioritize it on people who can spend money now, and our onboarding teams are going to prioritize it on which ones gave us the least headache. Because onboarding is a bit of a journey, and like I said, there's one step that's kind of before this. We've touched on all these points through this conversation, but here it is on a slide for you to see. How do we do this? And step kind of pre-step one is compatibility. And that's really what Ryan is significantly involved in. So when myself or someone on the sales team says, I want to do a building, you say, wait a second, we got to make sure we can do this building. So that's kind of pre-step one. Step one is that mapping and learning phase when we can plug in. And again, this is a huge hurdle that Commander helps us step over, because without Commander, we've got to do the whole thing where we source our own gateway, and we have to figure out the IT piece and parts that we're only playing out of necessity. But it's that mapping and learning piece. We've got to figure out what's in the building. We have to make sure it is mapped in a way that we can read it, and we map to Haystack. The step two we talked about, that's building that predictive model. And like Ryan said, I hadn't even heard that statistic where there was that kind of cap on, it wasn't points or bits or 100,000, 10,000. You said something, I don't remember, but
10,000 interval points.
Yeah, and this is kind of hard coded. Building that predictive model takes usually at least 2 months of just observing the building behaving and building the predictive model around that. Once we're past that, we enter into that continuous loop where we are live, we are affecting the site, and the AI is continuously learning. And so it'll adjust during a shoulder season, for instance. The first time it sees heating in a building, it's not going to try to optimize that because it's going to say, I've never seen this before. I don't have a model for this. It'll watch it a couple times, and then it'll be, okay, I know how this works. And it'll jump in. And that's the piece where it just keeps getting better and better. That's about all the content we had. So now it definitely would love to open it up for questions. I see there's
Well, here was one question asking about guaranteed savings. Does BrainBox AI guarantee savings?
No, and the simple reason we are dedicated to having our pricing model be really contingent on that utility savings piece. And if you look back, what it is our goal to be is to not charge any CapEx up front, because that's a huge barrier to entry to a lot of the market, and then make sure that what we're saving the client off their energy bill covers our cost. Do we have a guaranteed savings model, though? No. And the biggest reason for that is honestly, and Ryan can attest to how difficult this is the auditing and the math that would then be required to prove that. We want to get close, but if we guaranteed it, that's something that goes into legal paperwork that gets taken to the bank, and then everybody has to do a lot of math. And we're not a math company. Well, we kind of are, but not that kind of math.
Yeah, Cole, you're dead on. So guaranteed savings, at least the kind of almost legacy models now are a lot a lot of the headache and overhead associated with those types of offerings is kind of proving out savings efficiently and effectively month to month, or whatever the billing cycle is. M&V has been a trick all of itself with COVID kind of disturbing baselines in this last 18 months to 2 years as well. So kind of it was a good decision when we made it, and we'll stand by it now. The other side of that is really, at our core, we see ourselves as kind of a carbon reduction technology, more so than energy savings, although, both are important to different stakeholders. It's not lost on us that money is still a big contender in this market. But the broader kind of spectrum offering that we're trying to convey here is really an ability to help operate these complex systems that are installed and put in these facilities, where the users may not be, well trained, which is unfortunate, but that's the reality. So ideally, what we're saying is we can come in via AI presence, help you operate your facilities and your control systems with the mindset of we need to seek out energy savings, which is a difficult behavioral change to force into most operators anyway. So they're looking to reduce hot, cold calls. We're mindful of that as well, but we have this mindset for energy reduction, carbon reduction, whatever the stakes might be in your decision-making philosophy, kind of corporately. So if it's ESG, if it's dollar for dollar, we can weight those contingencies into our decision-making effort and run the building appropriately, or assist in running the building appropriately with that regard. So that's kind of, we see this as a service. We are assisting in the operation. We would expect that there is pull-through value in the energy savings piece, but that is not the singular target of what we're trying to do here.
Yeah, like I said, that's kind of the financing mechanism. But even, if we're looking at the major pieces of equipment and we can reduce their run times by 30%, that's extension of life on some massive capital assets. And I'll bet the dollar value associated with that is much larger than anything you could touch from a utility bill. So they're very exciting pieces here. You talk to an ownership group affecting their net operating income a couple points, and in the right market, that could add 4%, 3 or 4% to the property value as a whole. That's a very big number. So it all kind of rolls up. I've got a question here that I think might have been sent to me directly, and it said, what accounts for the difference between a 77% reduction and a 14% reduction in another building? So that would only be runtime reductions. We're never going to shave 77% of the energy usage off of a building. We are only talking about HVAC usage. So we're looking at affecting maybe 40 to 60% of that building's energy usage, and then saving a good portion of that out of the gate. But the difference between 77 and 14%, I would say that's how well was the building managed or scheduled to begin with. If you are very tight, if you're already paying someone to keep an eye on it, even just a little bit, it's not going to be 77%. 77% is going to come to us from a building that wasn't, being paid very close attention to. But even
it was just always on, or didn't have schedules set.
That's a 24/7 building.
It's a 24/7, exactly.
And they're also running heating and cooling at the same time.
Oh,
I've seen that many times.
Oh yeah, that's just as a schedule. Ignoring a schedule is one thing, but simultaneous heating and cooling is embarrassing. But that's what would count for something like that.
Exactly. Here's a question I received. It said, "Are you changing my programming or control sequences?"
I like this one because I have worked for other solutions that did. And that is a painful liability I am so glad that we do not have here. So it is a very technical, but very important to note that when BrainBox is making these changes, One, we're working backward from set point. And we don't change the zone level set point, and we don't actually change or permanently modify the sequence of operation at all. What BrainBox is doing is it's reaching out and it's just interacting with the building automation system through a series of temporary manual overrides. That means that your regularly scheduled program exists no matter what. If the internet disappeared tomorrow, oh my gosh, I hope that doesn't happen. If someone cut the cord on an edge device, you're just back to your regularly scheduled program. And that's why I really like that aspect about our solution.
Yeah, you can really kind of think of us, as much as I hate to use AI in this representation, as a virtual user. So rather than a user, chained to the workstation and making modifications 24/7, we're kind of a machine-to-machine version of that, making those kind of same decisions. The only difference between what we're doing and they would be doing is the chair needed to do it, perhaps, and we're using actual data-backed intelligence rather than kind of maybe thumb in the air, I know this building better than others mentality.
So you guys are also reducing chair manufacturing,
Yeah,
which I'm sure there's carbon associated with that as well.
That's a big target for us,
Yeah, but we're growing them out of, I don't know, something. Elon Musk's discarded rocket parts.
Yes.
Does my building have to have the same controls manufacturer throughout? I think this is a great question.
Do you have a building that has that now?
Yeah, I see. Yeah. So yeah, does it support different manufacturers in the same space?
Yeah, just I mean, the industry. If IoT is going to work, everything has to play nice. I mean, that's why BACnet is winning out in the long term. That's why Siemens is moving away from Apogee. Everything has to connect. That's why Commander is a great play for KMC. It's allowing them to bring that ecosystem together so folks like us can exist. Because if everything in the building can't play nice together, we can't do this.
Yeah, absolutely. And it's a bit of a loaded question because there's, I think probably most people on the call know, the myriad of different configurations, be it brand, vintage, islanded or not. I can tell you that we do have buildings. I've got one, I believe, in the Middle East that's 3 completely separate and individual DMS. So we've got kind of 3 gateway devices in that instance. Actually, I think we have 2 gateway devices and maybe a Tritium driver in that instance. But what that does is we still pull that up all into the same building neural network. So it's actually kind of a neat feature. So now we've taken these 3 disparate data sets, put them into one cognitive thought process, and if there's intelligence there to find, that's what we're looking for.
Yeah.
So being able to look at that holistically, although it's separate on the ground, is an advantage in our space.
Yeah. I mean, we need to be agnostic because we need to work with as much as we can work with. But you can get a sense from what Ryan is sharing what a headache that can be, just because, especially abroad, it's like you have a building. Oh, why did you put your air side and water side on 2 completely separate building automation systems? That just makes it difficult. And again, Commander in place, I have no further questions. Because that whole headache that is not our specialty has already been taken care of.
Yeah, absolutely. That's definitely a benefit of the Commander product line. It takes a lot of the kind of administrative headache that we can do, but again, we're an AI firm. We don't necessarily want to be all that burdened in data plumbing as we would consider it.
Data plumbing, I like that.
Yeah. Right.
So the Commander is a good bridge for us to hit these buildings, and it gives us the ability to act quickly, in points of interest. So if a customer comes to us, they are Commander enabled, as I'll call it. we can really get to work very quickly.
I had another question that was related to how you guys take control. I'm summarizing. Is this going to affect local overrides of the
Also, excellent, very technical question. I usually have a slide for this one, but I don't. So Ryan, I'll let you go for it.
Yeah, I'll preference it with "Do you want it to?" Because that's the truth of the matter. So we utilize BACnet for various things outside of it being a standard, but the priority array. So I'll talk in defaults, and obviously there's some room for variability there. Priority array, if those of you are familiar with it, 16 is kind of the default for most controls systems to speak out to the points they are trying to control, be that output set points or otherwise. Operator override is typically at an 8. Again, these are typicals, so there's flexibility in there. We can land anywhere you want us. Our default is in a 10 or 9 slot, such that we are overriding the local controls. So we have the ability that when the system is an auto, we are able to write and make it do what we want to do. We can then release that when we are not engaged. So the point being is our technology kind of engages and disengages throughout the day. So when there's opportunity, engage. When there is not, let it go, let the system run.
But the really important thing is, if you have, I put up the BACnet priority array. If you have humans interacting with your system on site, maybe priority level 4 or 5, like Ryan was saying, a manual override, you might have an operator who's at level 8. We're going to say, what is that? BrainBox is going to be right behind it. And that way a human is never fighting with the AI for something that a human wants to do.
And it's important to the fact that we've got other customers who have kind of said, we have an operator, loosely defined operator, or maybe they don't. Maybe they've had an operator that's come in and overridden things and it's been problematic. Maybe they want us at 8. Maybe they want us at 7. Maybe they want us to be able to override if they really want our technology to fully operate the building, we can do that as well. So there is flexibility in the implementation, and that's the discussion you need to have with the building owner, tenants perhaps, or the staffing that's usually monitoring these things. And from what I know of the kind of commander, kind of marketing, and it's light. Tim could probably school me on this, I'm certain. That might match with the market that you're going to with the commanders, people that are looking kind of a light touch BMS front end. Maybe there's not really a user in the building, so commander becomes this nice spot that we can go in and see what's going. We can help and assist in an operational presence or adder to that could be beneficial for all.
Yeah, just to add to that, many times Commander is used sort of as that light front end, right? So for smaller zoning systems or more simplified systems, then the other kind of dominant use case is bringing in together multiple different systems from, let's say, a school corporation or a portfolio to standardize the monitoring and visibility, and also kind of where all that data is being stored in an open way without having to do individual implementations or integrations with each one. There was one last question. I'll turn my camera on for this one, and this will be our last one. And it was, what if BrainBox loses connectivity being cloud-based? And what I would like to do is actually answer this from a Commander standpoint. Because Commander is that local instance of the interaction, there's kind of two components here. One is BrainBox will push a set point change into Commander, but then what happens is there's a timeout associated with it at the same time. So if you lose connectivity, that set point will only run for a limited amount of time before it then times out. And that's all then controlled locally. So if Commander loses connection to the internet, the last set point will still be there. It will time out after a short period of time. And then once we reconnect, BrainBox gets that data, goes right back into controlling the system as well. Anything to add from your guys' standpoint?
Nothing specific, but yeah, I think we're here to talk about the commander side of things. So that's a perfect note on that. We do have contingencies in our kind of, off the shelf offering. It's similar conceptually. If the command is lost or the connection is lost, we start pulling back things. So, local R device would pull those back in those instances, but
that's again the way that we're interacting with that system allows you to just go right back into your regularly scheduled program.
That's right. All right. Well, guys, with that, we will end our time together. Thank you so much, Ryan and Cole. Really appreciate you guys and appreciate partnering with you and being able to bring these smart building technologies to a whole new market for a whole new channel. We're very, very excited about that.
Yeah. So we'd just like to say, we're here. We're eager to work with a lot of you. We've got a lot of teams and a lot of resources standing by. If you've got buildings that are interested or teams that want to take another look, reach out. We've got more talented salespeople than me and a whole team of people that Ryan's working with that would love to take a deep look and maybe kick the tires of some of those buildings.
100% reach out to your KMC area VP, reach out to me, reach out to any of these guys, and we're happy to help you. So with that, we'll close it out. Thank you so much, everyone. Have yourself a safe rest of the week, and we'll talk to you soon.